Hi everyone. Today's tutorial will be talking about conditional programming. Now I'm going to show you some examples in Python and I hope this will make it easier for you to understand why we use high-level language in terms of conditional programming. Now assembly is a very low-level language, the lowest above hand coding the binary instructions pattern. This means assembly language is sequential because instructions are executed one at a time. Assembly language has minimal formal structure. Code can be fairly difficult to understand and modify. It is long and tedious to write. It's quite bug prone. Bugs can be very difficult to chase. Here I'm talking about bugs in terms of errors within the actual structure or the syntax or coding section. Code can be fairly difficult to understand and modify as well as maintain. So the result is non-portable to other architectures existing or upcoming. Now let's look at this conditional programming in Python. Now this condition can be used in several ways, most commonly in if statement and loops. And if statement is written by using the if keyword. Now, if you look at this example, we have here a with two variables. We have a and b. A is equal 33, b is 200. Now, if the condition is true, if b more than a, which obviously here b is more than a, then perform an action. So in this situation, if b more than a, print b is greater than a. As you can see here, b is greater than a. If I try to switch b less than a, then you will get an error straight away. So let me show you here this example. So if I run it, so here we have these two variables, a and b. So if I run it, so straight away, as you can see here, b is greater than a. As you can see, no errors. So consider for a moment a function that takes a value a and ensures that it is positive. This is called absolute, often written as ABS. Sequentially, we may write it as line 1, lookup table 21012. Line 2, a equal get value, random values, -2, -1, 0, 1, or 2. A lookup table a plus 2. Now for larger values, even 8-bit signed values, this quickly becomes an unreasonable method for writing an absolute function. For the CDM8, we potentially would need to provide 256 lookup tables, which uses the entire memory bank. So consider that this is also one of the simpler algorithms. More complex algorithm will surely use much more space using basically different methods. So if we, for a moment, revisit our conditional approach, we may write the following. A equal get value, some random value. If a less than 0, a equal minus 0. This approach is simpler and will scale much better to large programs. So if statement in Python condition and if statement. Python supports the usual logical conditions from mathematics. So what that means. For example, if I want to say a equals b in Python, I would do a equal b. If I want to say a not equal b, then a exclamation mark equal b. That means a not equal b. Now, this is easy. A less than b, less than or equal a less than or equal b, greater than a more than b. As you can see, the greater than symbol, we all know it. Greater than or equal, here the same thing. These conditions can be used in several ways, most commonly in if statement and loops. So in computing, the term Boolean means a result that can only have one of two possible values, true or false. Boolean logic, or also we refer to it as data type, takes two statements or expression and applies a logical operator to generate a Boolean value that can be either true or false. So Boolean is a data type. Just like we have, for example, name. This data type is string. For example, 5. this data type is integer. So we perform a comparison of some form, and this evaluates to either true or false. A and B could be anything. So if we wish to check a single value, for example, A, we may choose to compare it against 0. So for example, we check whether A is negative by comparing it to 0. So if A less than 0, perform action if true. We're going to have a look at other examples in a minute. So in assembly, we either TST, test one register, or compare two registers. We refer to it as CMB. Additionally, we can also have conditional logic based on the result of computation. So let's have a look at this example of Python if else. The if else or else if keyword in Python way of saying if the previous conditions were not true, then try this condition. So we have here again two variables. We have A and B. A equal 33, B equal 33. If B more than A, if B more than A, then print B greater than A. Else if A equal B, then print A and B are equal. So let's have a look at this example. Here, as you can see, if I run it, straight away here it tells me A and B are equal, because here I'm using A equal 33, B equal 33. So if B more than A, then B is greater than A. So if I change B to 34, okay, and I run it, now you will see it's going to say B is greater than A. If I'm bringing back to 33, then as you can see, this condition says A and B are equal because A is 33 and B 33. So I said if B more than A, then print this first condition, which is B greater than A. Else if A equal B, then print A and B are equal. So in this example, A is equal to B, so the first condition is not true, but the else if condition is true. So we print to the screen that A and B are equal. Now the else keyword catches anything which isn't caught by the preceding conditions. Example, A equals to 100, second variable here, B equals 33. So if B more than A, which in this condition, B more than A, which is not true, print B is greater than A. Else, A equal B, which again here is false, B does not equal A, then print A and B are equal. Else, print A is greater than B, A, which is true. So let's have a look. This example. If I run it, as you can see, tells me A is greater than B, and here the else condition. So in this example, A is greater than B. So the first condition is not true, false. Also, the else if condition is also false. So we go to the else condition and print to the screen that A is greater than B. Conditionally assembly, or we can call it assembly if, conditional assembly or assembly if. If statement in assembly code, the convenient are somewhat close to Python. What we mean here is the similarity. So we begin our conditional assembly with the if statement. So if, we all know now if statement for a single register, TST, which is test the state of a single register. Here, the register R0, so is MI, so test flag R0 is less than 0. Perform action if true. So in this example, we test the general purpose register R0. If we find this register is less than 0, which is here minus, we run the next section of code. If the condition is not met, we jump over this code to the FI section or perform action if true. So let's break down these as several components to the if statement. If, to tell the compiler that we are starting an if statement. Check. Here we perform some checks that raises flag. This could be a calculation, test of a single register, or comparison of two registers. Is a flag set. This performs our following code condition where we check whether a flag is set. Code, the code is to run under the right condition. Fi simply if reverse to indicate that the end of the if statement is reached. So if statement for register comparison, if compare register 0 and register 1. Test, so here is test if flag set for register 0 is less than R1. Perform action if it's true. Now end if statement. Lastly, we have comparison of two registers. Here we use R0 and R1. Now can investigate the flags raised as a result of this comparison in this case, which is less than. Check. So remember that comparison just checks the difference between two values. And as you can see here, we have the 4-bit comparison circuit. Assembly if else. Like Python implementation, we introduce else in the same manner. So if else for a single register, if test R0, test R0, register 0 of a single register is minus test flag R0 is less than 0, then perform action if true. Else perform action if false. So again, we use here the difference in using TST or test and compare for testing values. We could also, for example, use add and then check the resulting flag. So if else for register comparison. So if comparing R0 and R1, test if flag sets for R0 less than R1, then perform action if it's true. And then here we go back again to Boolean if it's true or false. Else perform action if it's false. End of is if statement. So as you can see here, you see a picture of how we use high-level language when we use condition as well as when we use assembly.